was wrong to say I wouldn't change a thing, 'cause in the story of our lives, the best of times through color glass, time rolls on enough to let me move on past, but every little now and then it creeps on back to shape my smile.
Hello.
Okay, Sensei, maybe you will start.
Okay, let's start the afternoon session. So the next speaker, lecturer is excuse me, えーと、
Iwayan.
Iwayan Gede Astawa Karang Sensei. And the title of his talk is Environmental Remote Sensing. So, Karang Sensei, please.
Okay, thank you, Sensei, Professor Ito Sensei, Professor Bibin Sensei, and all of you, student from KGU and also from the university. So today is my turn to say to deliver about this. Maybe this is the third topic, yeah, third topic among the previous Sensei. So this today we will talk about environmental remote sensing. Yeah, more fundamental. Yeah, more fundamental about the remote sensing. So for the KGU student, so this is my name. Yeah, already introduced by the sensei and Bibin sensei, and this is my email. If you later on, if you have if you want to discuss and interested about the remote sensing, you can send email to me. Okay, the content of today's lecture is first, I will explain about the fundamental of remote sensing, and maybe after break, I will try to show you about the application of remote sensing in the coastal environment. So because as so say explained before that mostly a student from KGU is the first grade, so I try to make as simple as I can to more easy to understand about the remote sensing, because this subject is more basic, yeah, basic and yeah, interesting, but to need uh, basic of basic about this topic. So let's we try first from the yeah preview how to say we Indonesia is facing the huge tsunami, yeah, in 2004, yeah, actually 2004, and we know that that tsunami is one of the largest how to say impact on the Indonesian area and the surrounding area, including the Indian Ocean, yeah, India, Thailand, Malaysia, and other countries also affected by this tsunami. And how we uh, understand about the condition after tsunami is most important for us, for researchers, actually for the remote sensing scientists, yeah, because for rapid assessment about the impact of tsunamis can help many people, yeah, how to evacuate and which the priority of area that has loss, yeah, and later on how we develop redevelop the area. The one of the example image from the satellite data from the quick bird, yeah, quick bird satellite, and this figure took I think several months before the tsunami. Yeah, June, actually June 2004, and we can see clearly from the data that the Banda Aceh, yeah, this is Banda Aceh city, and a beautiful city in Sumatra Island, yeah, quite about the maybe 2,000 kilometers from Bali. Yeah, 2,000 kilometers from Bali. So we didn't see any to say anomaly in the city from in June 2004. However, with the same satellite data, yeah, from the QuickBird, so we have another image post tsunami after tsunami. So we can clearly see that big change. Uh, uh, no single primary color can be created from the others color. So that's why RGB is the primary color of on the visible spectrum. So this the you can remember again, remind again about the this experiment or this practicum in the senior and junior high school about how the to say the uh, uh, a rainbow color. Yeah, yeah. Actually, I still remember how a rainbow, we can see the rainbow color when some the white lights pass through the prism. So this is because the visible spectrum. The next spectrum is the infrared. Yeah. So or IR. So this I'm to say the range of this infrared spectrum is from about the 0.7 to the 3 micrometer. Yeah. So this infrared is also is very common wavelength that also operate by the sensor to measure the Earth surface. Yeah, because by this sensor we can receive the emittent, yeah, emittent of the object. For example, thermal infrared. For example, it's used to measure the sea surface temperature, for example, in the ocean, and also land surface temperature also. Yeah, to measure the to say the heat energy that emitted by the object and perceived by the sensor infrared. So this is the infrared sensor. And next one is the microwave spectrum. Yeah. So the region of this spectrum is about 1 millimeter to 1 meter. So these regions cover the longest, yeah, the longest wavelength used for the remote sensing. For the space remote sensing, there's the radar or synthetic aperture radar that use this wavelength. Yeah, in the visible band, we to say so. All remote sensing system have four type of the resolution. Yeah, a minimum of the data requirement. First is we have a spatial resolution. The second one is the spectral, and the third one is the temporal resolution, and the fourth is the radiometric resolution. Yeah. So we will discuss one by one. So spatial resolution. So what is the spatial resolution? Yeah, we can recognize from the word, yes, spatial. Yes, spatial. Spatial mean the space. Space mean the distance or mean and then large area covered by the pixel, yeah, means low spatial resolution and vice versa. So when to say, well, the one a single object can be distinct or can be discriminated with the neighbor or with another object, that's mean there's the spatial resolution. Yeah, for example, we can recognize the how to say the lake or forest or road or hospital or something, that because of the this spatial resolution. yeah, this may be more easy to understand about what is the spatialization from this figure. Yeah, so this uh, but different type of the spatial resolution from the half of square meter. Yeah, 0.5 times 0.5 meters. So and then more to say low resolution. Yeah, when the covered area wider, this means the more lower resolution. So you can see from 1.1 meter and then 2.2 meter will more to say the information will more difficult to recognize, and then 5.5 5 to 5 10 to 10 until 80 to 80 or almost 100 to 100 orbit. Yeah, for example, I talk what I talk is satellite data. So satellite data has a orbit. When the we reduce the altitude in order to increase the spatial resolution, but we, of course we have to say we reduce also the temporal resolution. Yeah, temporal resolution can increase when the altitude we also we add the altitude. Yeah, because more higher altitude we're more quick to scan to the about the surface area. So this is the consequence. Of course, theoretically yes, it's possible, but ideally I think it's difficult. That's why each platform has its mission and its characteristic. You can see you can compare Moody's data and Landsat data. Yeah, Moody's data is mission is for the weather, for the this is for the global forest for globally purpose, but Landsat for lens land change. Yeah, uh, that's why Moody's has more higher latitude and more high temporal resolution because the altitude almost Moody's is about how more than 10,000 kilometer, but Landsat is only 1,000 kilometer. So that's why the different resolution. I think that is my answer, Shanley. Thank you.
Okay, thank you very much. So time is over. So okay, maybe we can close now. So you can take a rest, or maybe you go to restroom.
So can you see the slide?
Yes.
Okay. Uh, okay. Good morning, students. Okay, I think I repeat again. So today, this morning, I will explain briefly about the student tasks for each group and for preparation for the next presentation on term of environmental remote sensing. So I think this not so to say many explanation, just a simple task. So first, as already you creating the group previously, so first use that group. So this class will divided in three groups, similar with the previous lecturer, and each group will presenting one topic from environmental remote sensing. So I created the topic as you can see on the slide for group one. Group one, please make a presentation related to how differentiate between light that is absorbed, reflected, or emitted with the familiar context. So, mean what is familiar context? Mean what is happen in your for example daily life or in your is free for case study between in your life or maybe in advanced technology, for example satellite uh, uses for the environmental study. So, for example, explain why object is visible to your eye, and in particular, describe the path that light takes that allow you to see the object. I think this I will give the two to say books for this task. For the second group, please discover how infrared lights is related to the temperature and emitted lights. And group 3, please discover and describe what is different of active and passive remote sensing, including advantages and disadvantages. So that's the term of the presentation for each group. And next, please discuss the title and content. So, and each group will be leading by the one group leader to facilitating the discussion. And each member has a specific task, I mean individual task, and please describe it in on PowerPoint, including the explanation. And finally, you combine the PowerPoint in good presentation and will presenting in maybe in the last day in environmental remote sensing, I think in
Yes.
August 28th. So after this, I will send to Professor Bibin Sensei about the PDF of my textbook for as your reference. But you can explore it on other reference in internet on Google on other sources. I think that's my presentation for the student talk of environmental remote sensing, Sensei. If you have any question or comment, I think you can ask now before you go to the enter the break room.
Hello, Sensei. I
Right.
think we can ask student to start here. Come to the breakout room. I already prepared.
Yeah. So please enter the breakout room. If you don't have any question to get the Karan Sensei. Okay.
Hello, student. Any
Okay.
question?
I think easy tax, yeah.
Oh, you will wait for Gede Karam visit your room, okay? Directly, okay. You will ask Gede Karam privately. Come to
Yeah,
your.
it's okay. So I will ready for
Okay.
next 1.5 hours to maybe for each group. I will visit each group if you have any question or discussion later maybe. Okay, so how distribute the PDF file, Sensei? Can I send to Professor Bibin?
Yeah,
Yeah.
please send the Professor Bibin.
Okay. You can send. I will send to the student by via email.
Okay.
Thank you. So please join to your come to your room. Door is open, so you have a key. This
Okay.
access.
Already make a note, yeah, about this task for each group. So before I close this, because I stop the share content.
Yeah, the PowerPoint, please.
Okay. So please start working and prepare your presentation. Maybe for you have to say about 2 weeks, yeah, almost 2 weeks
Yes.
preparation for your
Maybe 2 weeks more,
presentation.
I
I
think.
think the longest preparation of
Yeah.
among the lecture. Yeah. Okay.
Yeah, more
Okay, can I stop and say the slide?
Yeah, please stop.
Yeah, you can stop.
Does everyone already receive the books?
Yeah.
Sorry.
Yeah,
Or
I think
maybe-
I have received the book on my email.
Okay. I think we could just skim it a bit, read it pretty quickly, maybe just from the contents. So gather maybe if you have any more ideas other than the one that I've already said before. Wait, yeah, you better. I think we should open it for a bit, just to make some point of view.
recording.
Yeah.
Okay, okay.
For group 2, is there still a question or comment? Or you can walk now? Peter, okay?
Okay, sir. I think
Okay.
we're gonna find some literature first.
Okay, thank you. Good.
Yes.
So thank you. So I will leave the room now. If you have any question, please maybe you can join again to the room too. Okay, please send message to Bibin Sensei, and I will join to the your room again. Okay, thank you. So keep working.
Thank you.
Any question? Or everything is clear and you can continue to work? Okay, all good, yeah? Who is the leader? Who's the group leader?
The leader is Margaret, sir.
Margaret, okay. Okay, if there's no question and no comment, I can leave you and please keep working, continue working and make a good presentation.
Alright, sir.
What to say? Good story, good storytelling, yeah, about the passive and active remote sensing, and please give us one or two example about that, yeah, that application. For example, one in passive remote sensing and one in active remote sensing. It's free. You can take from the daily example, or maybe if possible, you can from the literature you can uh, describe about the satellite data. Also, it's okay. So I will leave the room. So continue. Please continue to work.
Alright, sir. Thank you.
Okay.
Okay, guys. I think because not everyone are familiar with this topic, let's go with this 9 point first, and then let's give it a search, give it a browse. Maybe we could read the books given by Professor Karang first, or we'll just look it up on Google's. And I think after that, if you found something that's bothering your mind about the topics, you could just like talk it here, and we could revise these 9 subjects that we have choose. Yeah, that's because I think it would be more flexible. How about it? Let's just give it a go with this 9 topic first, and if you find any maybe obstacle or certain topics can't be explained specifically, we could just revise this 9 topic. How about it?
Okay.
If it's all right with you guys, all of you?
Tim, I want to ask first, did the absorb, reflect, and emit light is related to scattering?
Yeah, actually the scattering is, I think it would be explained in the fifth, like the relation between absorbed, reflected, emitted. I know like the refraction on like the water, right? Uh, I'm not sure does which which topic it would be explained at, whether it's the topic number 3, the reflected light, or the topic number 5, the relation between those three. But yeah, I think it cover about the refraction.
Yeah, because I remember that Professor Karang before uh, he is explain us about scattering, like back scattering, my scattering, something like that. I think it's uh so many material. Like I don't know, should we add it like scattering rather than relation between absorb? I don't know. Did you get it? Because
Yeah, I get.
I remember that few material like so many scattering Professor Karang explained before.
Wait. I'm gonna stop sharing. Let's look the presentation, the Professor Karang presentation.
The example, but if but we must to relate to our topic. If there's no relate, that we cannot to get in.
Mm-hmm. Okay.
I think for this topic, to get our example for this topic is too hard to find. We just maybe these five main topic is already good enough or not, guys? Yeah, guys, you can see in line chat that Rati is already gave explanation in there. Maybe I will copy and paste in our Zoom chat. This one. Eh, share screen. Maybe I will uh, do it like topic before, and I will wait, wait, wait.
Sorry, I am leave return time. Okay.
Okay.
Yeah. Uh, mm, can you see my share screen or not?
Okay, because it's been divided to all people, let me check the. So for this session, we actually have till 8:40. It's all sorry, 10:40. It already 10 and 3 minutes. We have about 37 minutes left. How about that we check out and browse, look up in the Google, maybe in some books until 10, 10:25 maybe? Okay.
Yeah, I'm good with that.
Okay, let's check out it first in internet, anything. And you should check out if any of you found obstacle or anything you are get bothered about the topic that you have chosen. It's fine. After 10:25 we could get back here to discuss it. If any topic want to be revised, it's okay. It's for the preliminary search first. Is it fine?
And visible light similar or different?
Sorry, ma'am,
Sorry, once
please.
again, please.
Wait, yeah. I'd like to ask, is the emit light and visible light similar or different?
Emit light and visible light.
Yeah.
Sorry, I'm not sure well either.
Temperature in the ship. Ah, is this film? 見えない。Thank you. Okay, I see. 具体的なイメージがつかめるようなものを、
Infrared light.
infrared light.
I'm sorry. Infrared. Oh no, infrared light.
Infrared light.
Please look at.
Oh yeah, and about the environmental remote sensing, I think it's you don't have to rush. You could take your time to understand it because the final for the environmental remote sensing is still at 28th of August. It's still so far, so we have a lot of time to learn it. Okay, it's already 10:40. Excuse me, Professor Wibin, is it all right if we go to break? Okay.
Okay, no, time is up. So you can break or you can stay in the breakout or you can go to the or you can leave room also. It's depend on you because next we are going to have a presentation preparation again with what is it? Professor Gede Hendrawan, yeah?
Yep.
Okay, so please you can go to restroom or to have a breakfast maybe. Some of you don't have
Good afternoon, everyone. So today we will start the final presentation for environmental remote sensing topic. So I think this morning all of you already presenting your result about another topic, yeah, except with Professor Bibin Sensei, I think. So now let's start. Please appropriately start from the group one. Hello, group one. Can you hear me?
Good morning, sir.
Okay, Stanley, and your team, please
Timothy, sir.
start your.
Timothy, sir.
Oh, Timothy. Okay, I'm sorry. No, today I'm so many obstacles in
It's okay,
my,
sir.
my side. Okay, okay. So everything fine, yeah. So Timothy, can you prepare your slide and you can introduce your team briefly and start your presentation. Yeah, so time is yours, Timothy.
Yes. Thank you, sir. I would like to share my slides. Good morning again, everyone. This time, Group 1 would like to present it about environmental remote sensing, especially about differentiating between light that are absorbed, reflected, or emitted within a familiar and easy context. So, this group consists of 9 people, but one of them couldn't attend this meeting, which is Jovita Larasapitri, and the other are Putu Wilandari, Echa Aryunisa, An Agung Ole, Abelia Oksana. There are Kawasaki Kai, Hikari Harada, Shogo Shiroyama, and me myself, Timothy. And so for the first topic, which Hikari, please.
I will Next, please. I will explain the basic knowledge of light as a wave. Our surroundings are full of various kinds of light, such as natural light from the sun and distant stars, and artificial light such as lamps and televisions. These lights can recognize color and shape of an object by directly or indirectly entering our eyes, that be our remote sensor. With the various types of light, the light that the human eye perceives is called visible light. Its color depends on the frequency or wavelengths. Firstly, I will describe about the relationship between wavelengths and frequency. Frequency refers to the number of cycles of a wave passing a fixed point per unit of time. Frequency is normally measured in hertz, equivalent to 1 cycle per second and various multiple of hertz. The wavelength is the length of one wave cycle, which can be measured as the distance between successive wave clusters. Wavelength is usually represented by the Greek letter lambda. The relationship between wavelength and frequency can be expressed as speed of light equal wavelength times frequency. Therefore, the two are inversely related to each other. The shorter the wavelength, the higher the frequency. The longer the wavelength, the lower the frequency. Second, I will explain about the relationship between the wavelengths and color of visible light. The visible wavelengths cover a range from approximately 0.4 to 0.97 micrometer. The longest visible wavelength is red and the shortest is violet. Generally, light often refers to the visible light, but it may also include ultraviolet rays and infrared rays. Thirdly, I will explain white light and monochromatic light. Light that contains light of various wavelengths, such as sunlight, and does not fill a hue is called white light. Light consisting of one wavelength is called monochromatic light. Finally, I will explain how electromagnetic waves are transmitted. Light is a type of electromagnetic wave, same radio waves, and it is transmitted even in a vacuum without a medium, unlike water surface waves and sound waves. Electromagnetic radiation consists of an
electrical field E, which varies in magnitude in a direction perpendicular to the direction in which the radiation is traveling, and the magnetic field M, oriented at right angles to the electrical field. Both these fields travel at the speed of light. The above is a basic knowledge of light as a wave. Thank you.
No, really. No,
It's clear, Will.
no.
Okay. Now I would like to explain about the absorbed light. Next, please. Okay, absorption is the other main mechanism at work when electromagnetic radiations interact with atmosphere. In contrast to scattering, this phenomenon causes molecules in the atmosphere to absorb energy at various wavelengths. Ozone, carbon dioxide, and water vapor are three main atmospheric constituents which absorb radiation. Because these gases absorb electromagnetic energy in very specific regions of the spectrum, they influence where in the spectrum we can look for remote sensing purposes. And those areas of the spectrum which are not severely influenced by atmospheric absorption and thus are useful to remote sensors are called atmospheric windows. And by comparing the characteristic of the two most common energy or radiation sources, the sun and the earth, with the atmospheric windows available to us, we can define those wavelengths that we can use most effectively for remote sensing. The visible portion of the spectrum to which our eyes are most sensitive correspond to both an atmospheric windows and the peak energy level of the sun. Next, please. A chemical compound in leaves, radiation is not that is not absorbed in or scattered in atmosphere can reach or interact with the Earth's surface. There are three forms of interaction that can take place when energy strikes or incident upon the surface. These are absorption, transmission, and reflections. And the total incident energy will interact with the surface is one or more of these three ways. And the proportion of each will depend on the wavelength of the energy and the material and conditions of the feature. And absorption occurs also when the radiation or energy is absorbed into the target, while the transmission occurs when the radiation passes through a target. In the picture, you can see a chemical compound in leaves called chlorophyll strongly absorbs radiation in the red and blue wavelengths, but reflects green wavelengths. Leaves appear greenish to us in the summer when chlorophyll content at its maximum. And for the water absorption, you can see a longer wavelength visible and near infrared radiation is absorbed more by water than shorter visible wavelengths. And thus, water typically looks blue or blue-green due to stronger reflectance at these shorter wavelengths, and darker if we view at the red or near infrared wavelengths. And if there is a suspended sediment present in the upper layer of the water body, then this will allow better reflexivity and the brighter appearance of the water. And the apparent color of the water will show a slight shift of the longer wavelengths. Thank you.
Okay, daily life example of absorbed light. Next, please. Why does black clouds feel hotter? Light and heat are both energy, and energy can be converted from one form to another. Light energy convert to heat energy when the light is absorbed. When an object absorbs more light, it produces more heat. Dark colors absorb a lot more heat than lighter ones because they absorb more light energy. Black is the ultimate heat absorber. It absorbs all light on the visual spectrum, creating a void of light as a result of absorbing a light wavelength. Thank you.
Thank you for the time. I will explain about the daily life example of reflected light and how it works. The first is object seen due to the reflection. Why we can see the object in our surroundings. An object placed in a light room or to any other source of light, then it emits some source of light from itself. When this light wave get reflected from the object placed on that room, and when the reflected rays enter in our eyes, it forms a virtual and inverted image in the retina. To seeing an object, there one important thing is light. Without light, it's not possible to see an object through our naked eyes. Next, please. And here the other example, the reflection from luminous object and the reflection from non-luminous object. Luminous object emit a light wave from itself, and when this light wave collide with any other object or non-luminous object, it makes us to say that non-luminous object. So due to the reflection, or we can say with the help of reflection phenomenon, a non-luminous object can be seen. In other words, due to reflection of light, a non-luminous object becomes luminous object and can emit light wave. Thank you.
The major use of LED or like emitting diodes are to illuminate objects and even place. Its application is everywhere due to its compact size, low consumption of energy, extend lifetime, and flexibility in terms of use in various application. And application use of LED can be seen in TV backlighting, smartphone backlighting, LED display, automotive lighting, and dimming of lights. And how does an LED work? LED lights work very similarly to standard light bulbs, except for the fact that LED are much smaller and contain no filament. Instead of a filament, an LED creates light using nothing but the movement of electricity along the path of its semiconductor. As the electrons stream across the semiconductor, they create electromagnetic radiation, and some form of this electromagnetic radiation can take form of visible light, which human can perceive via sight. Thank you.
Okay, so now we are at the last part, which is I would like to tell you to explain about the application, the connection between all of these light characteristic, which is reflected, emitted, and absorbed in the application of remote sensing technology. So in this presentation, I use one particular study that are created by Purwanto and Asriningrum in 2019. Both of them try to identify mangrove forests, to classify mangrove forests apart from other vegetation through using multispectral satellites, namely Sentinel-2A and Landsat-8. Multispectral satellites generally are satellites that have a lot of bands. So it has been explained in the beginning that the electromagnetic wave, which means light, have a lot of wave. Depends on the wavelength. It's a lot of them. I mean, depends on the wavelength. There are like visible light, and then infrared, ultraviolet, and a lot of the other. So multispectral satellites have each different has a sensor that could read all of this wave and write it down as a value. So in this study, they use Sentinel-2A and Landsat-8, and from this study, they classify that there are 3 bands usually used and really good for identifying and classifying mangrove forests apart from other vegetation, which is red H, shortwave infrared, and visible red. So all of these are actually looks like red. Why they use this band combination? Why? The reason mainly are the first one, the red H, mainly used on vegetation identifier. And so I think that's all that Group 1 could explain for this time. Thank you. I'm sorry for any misconduct in any words or action. And if you have question, please ask away.
Okay, thank you, Timothy. I think very excellent work, yeah, excellent presentation from group one. Yeah, actually, we still have a lot of time. Yeah, I think about continue to the question answer session. Yeah, I would like to invite this other student first. If you have question or comment for group one work, I think this is an excellent work because very balanced, let's say, content from all member. Yeah, I think all member has a great presentation. Maybe from group 2 or group 3, if you have question, comment.
Excuse me, sir, I have a question.
Okay, please.
I would like to confirm about the final topic. And is that a measurement that using the difference between the absorption of the visible red light and infrared light, and by using the different absorption, they use it and measure, right?
Yes, the satellite are measuring each band that could be identified by the sensor.
I see. And thank you for your answering the question.
Okay.
Maybe I want to ask, but I forgot the worst part slides. I want to ask maybe who I want to ask who's do share screen for this presentation team.
I'm sorry, Stan, could you repeat that?
Yeah, I want to ask, but I forgot the question for the other slide. Maybe you can replay more presentation before, so because I forgot.
Okay, I'm gonna change the slide.
Yeah, the right one. Yeah, maybe next one, next one, next one, please. Next one, 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 next one. Yeah, maybe in the slide in between correlation, then Tim. The topic of experience, the topic of correlation about bands.
Oh, it's my topic. Wait.
Yeah, part 7 or part 1? Sorry.
This one?
Next one, next one. Yeah, yeah, this one. Yeah. I want to ask a simple question, but maybe can you give me give an example project or give example study case for this band combination, so I can know to how band combination to I want to describe. Maybe the simple example or study case for that best band combination.
Yeah, this topic I read from this particular journal. It's called Identification of Mangrove Forests Using Multispectral Satellite Imageries from International Journal of Remote Sensing and Earth Sciences. Written by Purwanto and Asriningam. So in this study, they try to define which band combination that are the best for specifically to classify mangrove forests apart from other vegetational, like say maybe grass and things like that. And so they found on their study that these three are the best band combination. Contrary to sometimes we use like the combination of red, green, and blue, the regular visible light band to see, but sometimes if you use those RGB, actually, you can differentiate between, like say, a mangrove tree and like say an oak tree, which are, let's say, both are green. How do you classify, how do you identify them apart? That's why Purwanto and Asrining Room try to define which one is the best band combination, and they found these three: shortwave infrared H, shortwave infrared, and visible red. And yeah, the study I'm reading is the study is actually the case, the study case you are talking about.
Oh yeah. The next question is, how about if I want to use this bin combination, can I use for Seagrass study cases for Seagrass project for identification Seagrass?
Okay, I'll try to answer that. I'm not an expert also in the remote sensing, but I've read a few journals. But there would be a different parameter that I use. This study that define the best band combination between for the classifying mangrove are not accounted for water. We know that mangrove are in the surf, like in the land, right? Maybe they are at the estuary, they are at the wetlands, but they are not under the water. But if you're talking about seagrass, they are under the water. So the short answer is no. You can simply just took this three band combination to like identify seagrass. But maybe one or two of this band could be used, because you need, again, I say that you need to calculate the effect of the water, because the seagrass again are underwater. So maybe not all three are usable in that sense, but maybe one or two are usable.
Yeah, I think for now that's already clear, Timothy. Maybe that's all my question, Mr. Karang.
Okay, thank you, Stanley. Stanley from group 2, yeah? 3 or
Yeah,
2?
I'm from group 2, sir.
Another way is, of course, there's a numerical calculation or modeling, yeah, to complete, yeah, to complete the in situ data or the ground truth data. If there is no information covered by the satellite data. I think that's my additional comment for group 3 discussion. So I think time now is finished for all presentation. I think all group has excellent work, excellent presentation. So please give big applause to all groups. Yeah. So finally, before you move to the break time, yeah, and continue to the next final presentation. So I want to say that I really appreciate to all students that very with hard work and then good coordination to complete this presentation. Yeah, yeah. I knew that especially for the Kaiju student, this is maybe this very new topic, and maybe this is the first time heard about this topic in your maybe in your life, yeah, because remote sensing is not for all a subject in the school, but now you prove that you can make a good presentation and understand the basic principle of the remote sensing itself. I think this maybe will useful for for your next journey, yeah, when you find something interesting on in remote sensing, and you can use this knowledge. Yeah, I think that's all message from me. So thank you for your presentation. Then I will back this session to the Professor Bibin Sensei. Can you hear me?
Okay, thank you very much.
Okay.
So, okay, I think no. Hello, To Sensei. We are
Yes.
going to close. Yeah, we are going to close this session.
Yeah.
And
And
then
when next session will start?
yeah, the next session will start 15:40.
15:40. Okay.
Yeah, we still have time. So thank you very much. Professor Gede Karang. And don't forget, Professor Gede Karang, maybe in the last, in the closing ceremony, we are going to request your.
Okay, Sensei.
Okay. Thank you very much,
Okay, Sensei.
everybody. So you can take a rest.